Hello everyone. In this video, we will be solving algebraic equation using the bisection method. In this series, we have 4 different methods that we have tackled, but we have only used one example or one equation so that we can demonstrate which of the following methods is best suitable for you, either in terms of memorizing the algorithm or the easiest way to arrive to an estimation of the solution for the equation. The bisection method is a simple method because we only intend to memorize a simple formula, which is basically just an average of the x sub l and the x sub u. The algorithm for the bisection method is number 1, compute the first estimate of the numerical solution x sub m by using this given formula. Number 2, determine whether the true solution is between a or x sub l rather and x sub m, or between x sub u or between x sub m and x sub u by checking the sign of the product. So we need to check the product or the sign of the product of these two values, f of x sub l and f of x sub m. If their product is negative, the true solution lies between x sub l and x sub m. Therefore, in the next iteration, we will be changing the value of x sub u. If the product of these two, on the other hand, is positive, the true solution lies between x sub m and x sub u. Therefore, we will be changing the value of x sub l in the next iteration. That two conditions are pretty important to arrive in the correct answer here using the bisection method. Step 3. Set new intervals based on the conditions that were given on the step 2. And then we will be repeating the steps from steps 1 to 3 until we have attained the specified tolerance or error bound of the problem. We will now be arriving to our example. So the equation we will be solving is x squared minus 2 is equal to 0. If we rearrange or rewrite the equation, this is simply x is equal to square root of 2. So what we'll be finding right now is the value of square root of 2. What you now see on the screen is the table we will use for the bisection method. We have the columns x sub l, x sub u, f of x sub l, f of x sub u, x sub m, f of x sub m, and x sub u minus x sub m. So we will just simply insert the values and then compute for the x sub m and repeat the steps. So in solving the problem, f of x is equal to x squared minus 2. And we have these predefined lower and upper limits. The root of the equation lies between 1 and 1.5. So we have 1 and 1.5. The f of 1, simply by substituting the value of 1 into the x, 1 squared minus 2 is 1 minus 2, therefore negative 1. F of 1.5 is equal to 1.5 squared minus 2 is equal to 0. 0.25. So returning to our table, we could already put some datas in the table. Our lower limit is 1, our upper limit is 1.5, and then if we substitute these values into our equation, we will have -1 and 0.25. We will now be solving for the x sub m. So this is simply the average of x sub l and x sub u. So x sub m is equal to 1 plus 1.5 over 2. 1 plus 1.5 is 2.5. Then dividing it over 2, we will arrive to the answer 1.25. So here, I have inserted the formula, so we could just easily complete the table later, which will arrive to the answer 1.25. Inserting the value 1.25 in the x squared minus 2, 1.25 squared minus 2 is equal to negative 0.4375. So looking at the value of f of x sub m and f of x sub l, the product of these two is positive. Therefore, if the product is positive, or the sign is positive rather, we will be changing the x sub l here to the value of the previous x sub m. So x sub u minus x sub m, we complete the table, the row first, is simply 0.25. So repeating the steps until we complete the table and attained the proper solution, we will be arriving in these values. I've already pre-calculated everything just to arrive to the answer faster. You could practice this at home. We will see the solution at the column x sub m. We know that the first 4 decimal places of the square root of 2 is 4142. First 4 decimal numbers rather. So 1.4142. We have attained that value at our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th iteration. So bisection method needs a 12th iteration to arrive to this value with an upper and lower limit of 1 and 1.5. 1 to 1.5 rather. So here it is. This is the answer for the bisection method. And at this point, we have just solved it.